If you've been on social media at all lately, chances are your feed has been absolutely flooded with them. These incredible, vibrant photos of the night sky just glowing in shades of pink, purple, and green. And no, that wasn't a filter, it was a massive geomagnetic storm putting on a light show for pretty much the entire planet. So, what in the world was going on up there? Let's get into it.
Right? That's the big question. Why was this light show happening on such a massive scale, and in places that almost never, ever get to see it? Well, the answer actually begins about 93 million miles away, with that giant star at the center of our solar system. And when I say unexpected places, I mean really unexpected. We're talking about the northern lights being spotted as far south as Alabama, Ohio, Texas, even Northern California. These are places that normally have like a 0% chance of seeing this. That right there tells you something truly historic was going down. To really understand the lights we saw in our sky, we've got to follow the trail all the way back. And that means a 93 million mile journey to the source of it all, our sun. You see, what we witnessed here on Earth was actually just the grand finale of a super dramatic event that started right on the sun's surface. You know, what's really great is how scientists explain it. They put it in these really simple terms. It all kicks off when the sun, and I'm quoting here, burps out a massive burst of energy. I mean, what a fantastic and honestly a very memorable way to describe a truly colossal solar event. Of course, that solar burp has a more scientific name, a coronal mass ejection, or a CME for short. What it is, essentially, is this gigantic eruption of charged particles, protons, electrons, and magnetic fields, just blasting away from the sun's atmosphere at unbelievable speeds. So, how does that CME actually create the lights we see? Well, you can think of it as a four-step cosmic journey. First, the sun unleashes the CME. Second, that cloud of particles travels through space, and this time it was aimed right at Earth. Third, it slams into our planet's protective magnetic shield called the magnetosphere. And finally, that collision gets particles in our upper atmosphere all excited, making them glow. And that glow, that's the aurora. Okay, so why now? Was this just a random fluke? Not at all. The sun actually goes through an 11-year cycle of activity. It swings from a really quiet period called the solar minimum to a super active period, the solar maximum, where its magnetic poles literally swap places. This whole process creates magnetic tangles that lead to more and more CMEs. And here's the kicker. We are smack dab in the middle of that solar maximum phase right now. So we know this CME was powerful, but how powerful are we talking, really? This thing wasn't just any old solar storm. It was officially classified as a G4 geomagnetic storm. And believe me, that rating carries some serious weight. G4. You know, scientists use a 5-step scale to measure these things from G1 all the way up to G5. So getting a G4 rating means this was the second highest possible. It signifies a severe storm with the potential for some pretty widespread and significant effects. And to put that into perspective, NOAA's Space Weather Prediction Center, the folks who officially forecast this stuff, they said watches at this level are very rare. So when the official forecasters tell you it's a rare event, you know it's a big deal. They even said it had the potential to hit G5, the absolute highest rating. But here's the thing. All of that energy slamming into our planet does a lot more than just create some beautiful lights in the sky. A storm this big brings a whole host of potential risks with it, risks that we really have to pay attention to, especially in our super tech-reliant world. It's really a phenomenon with two very different faces. On one side, you have the undeniable beauty, right? The dazzling lights, those incredible photos, and just that feeling of being connected to the cosmos. But on the other side, there are some serious risks. A G4 storm can cause big fluctuations in the power grid. It can mess with GPS and radio signals, and it can disrupt satellites and even air traffic. And look, these risks aren't just theoretical. They're not science fiction. History is filled with examples of the sun's raw power. Back in 1859, a massive storm actually set telegraph lines on fire. There's even evidence that a storm in 1972 might have accidentally detonated US sea mines. So just imagine what a storm of that magnitude could do to our deeply interconnected, technology-dependent world today. Okay, so after hearing all of that, I know what you're probably thinking. How can I see this myself? And you know what? With the sun still in its active phase, you might get more chances. So here's a quick little guide to becoming an aurora hunter.
It's a pretty simple checklist. First things first, check the forecast. Use an official source like NOAA's website or a dedicated Aurora app. Second, and this is absolutely key, get away from city lights. The darker the sky, the better. Third, you gotta be patient. Look toward the north and give your eyes at least 15 minutes to fully adjust to the darkness. And finally, here's a great pro tip. Use your smartphone. Its camera can often pick up on colors and shapes that are way too faint for the naked eye to see.
So, we've seen how a little burp from the sun can travel millions of miles across space just to paint our skies with light, reminding us of both its breathtaking beauty and its incredible power. It really leaves us with a fascinating thought, doesn't it? As our star continues to wake up for its 11-year peak, what on earth will it show us next?